300 earthquakes in 24 hours just rattled a volcano linked to Oregon. If this was on land, evacuations would have already started. So, what's waking up beneath the Pacific, and how close are we to a new eruption? About 300 miles, approximately 500 kilometers off Oregon, an underwater giant called Axial Seamount rises from the seafloor. It sits nearly 1 mile, approximately 1,600 meters, deep on the Ring of Fire, Earth's most active belt for quakes and eruptions. It doesn't look like Mount St. Helens or Hood because it's hidden, but Axial is the most active volcano in the Pacific Northwest. Scientists have treated it like a living lab for years, and this week the lab started buzzing. The last time Axial ramped up like this, something dramatic happened. More on that soon. In the span of a day, 300-plus small quakes fired off beneath Axial. Most are magnitude 1 to 2. Tiny on paper, huge in volcano language because they often track magma on the move. Sensors anchored to the bottom, cables, pressure gauges, and cameras send real-time data to shore. One veteran oceanographer put it bluntly, "If this were on land with people nearby, we'd be evacuating." Why are small quakes a big deal here? Because the last swarm set off a chain reaction you could measure from space. Back in 2015, Axial went from tremor chatter to eruption. Quakes spiked to thousands per day, lava broke out along cracks, and the seafloor sank approximately 8 feet, approximately 2.5 meters, as magma drained from its chamber. That eruption poured out thick pillow lava. Rounded lobes formed when molten rock hits cold seawater, stacking up to approximately 450 feet, approximately 140 meters in places. Today's activity is smaller, but the pattern, swarm plus inflation, looks familiar. So what are instruments seeing now? Think of the volcano like a balloon. As magma refills, the ground inflates. After 2015, Axial's surface rose fast, around 2 feet per year, then slowed to roughly 8 inches per year. But it never stopped. Beneath the seafloor, roughly 800 meters down, a magma chamber pressurizes. Quakes pop when rock cracks as new melt squeezes through. If pressure crosses a threshold, where would the lava actually come out? Axial doesn't only erupt from a central crater, it's notorious for dikes, magma forcing sideways through fractures, opening lateral fissures that can vent kilometers away from the summit. That makes forecasting tricky. You watch one spot and the break happens over there. So if it erupts underwater again, what does that mean for people on the coast? The good news, Axial is remote and deep. Shaking isn't felt on shore, and a typical axial eruption is lava-dominant, not the ash blanket style that disrupts flights. Tsunami risk from this type of event is generally low, unless there's a large landslide or unusually explosive interaction, rare for Axial's history. But if the danger's low, why are scientists so dialed in right now? Because the network on Axial is better than ever. Continuous cameras and pressure sensors mean we could capture, for the first time in this detail, how a submarine eruption starts, peaks, and wanes, from magma ascent to seafloor changes. Those insights feed models for other volcanoes, including the Cascade Range on land, where hazards overlap with cities. Speaking of the Cascades, how does Axial's story connect to giants like Rainier or Mount St. Helens? The Pacific Northwest sits where an oceanic plate dives beneath North America. Offshore, that process fuels volcanoes like Axial. Onshore, it builds the Cascades, Rainier, Hood, St. Helens, Adams, Baker, and more. Each system behaves differently. Rainier's major concern is lahars, fast volcanic mudflows that can race down valleys toward Tacoma and Olympia, even without an eruption. By decoding Axial's pressure quake eruption sequence offshore, scientists sharpen tools that help anticipate and mitigate risks on land. So, does 300 quakes in a day mean an eruption is guaranteed? Number swarms can stall. Axial has a history of bursts and plateaus, but if numbers accelerate, if inflation jumps, or if instruments pick up magma rising in dikes, the probability climbs. Fast. And this time, we'll see it in real time. We'll track Axial regularly and break down what the data actually means, minus the hype. Subscribe to GeoSphere, drop a like if you learned something, and share this to keep others informed. Stay curious, stay prepared.